What happens when seafloor spreading exerts force on tectonic plates and causes them to diverge or converge? Since tectonic plates are fitted tightly, there isn't much room for them to move, so when seafloor spreading exerts force and causes them to move, they usually end up sliding over or under each other at places called boundaries. There are several types of boundaries, designated by whether the plates move towards each other, away from each other, or past each other. Boundaries at which tectonic plates move towards each other are called convergent boundaries. These collisions differ depending on whether the parts of the crust converging are comprised of continental crust, oceanic crust, or part of each. At a continental-continental boundary, or one between two converging pieces of continental crust, the collision forces the Earth to fold up. Since both pieces are roughly the same density, neither sinks beneath the other, and they essentially squeeze together. At boundaries between a piece of continental crust and oceanic crust, or continental-oceanic boundaries, the oceanic crust is denser than the continental crust. So when they converge, the oceanic crust actually sinks below the continental crust and dives back into the mantle, often pushing the continental crust up in the process. These areas where one plate dives beneath another are called subduction zones, which will come up again later when volcanoes are discussed. Oceanic boundaries behave more like oceanic continental boundaries than like continental boundaries. As oceanic crust cools and is exposed to millennia of weathering and erosion, it tends to increase in density. This means that older crust far from mid-ocean ridges is denser than younger crust near mid-ocean ridges. Since different pieces of oceanic crust have different densities, when they converge, one will usually sink below the other, again at subduction zones. The pressure and stress built up by converging crust often leads to the formation of mountains and volcanoes, and can also cause earthquakes. Boundaries at which plates move away from each other are called divergent boundaries. At these locations, magma can rise to the surface and further separate the two plates. Correspondingly, most mid-ocean ridges are on divergent boundaries, making them the primary sites for seafloor spreading. Transform boundaries are the final type of tectonic boundary. On any given tectonic plate, there may be some parts of its boundary that converge with neighboring plates, some parts that diverge, but many will move horizontally to other plates. At such transform boundaries, the two plates slide past each other rather than into or away from each other. However, tectonic plates are not evenly cut or smooth, so even though they are sliding past each other rather than into each other, there is a lot of friction between adjacent pieces of Earth on opposite crusts. This means that they don't slide easily, and stress and ultimately strain can build up in the Earth around such boundaries. When the ground succumbs to the strain and moves, the surrounding areas frequently experience earthquakes. The San Andreas Fault running through most of Southern California, and which is responsible for most of the dramatic earthquakes in American history, exists because of the transformed boundary between the North American Plate and Pacific Plate. Why tectonic plates ultimately move goes back to a topic that we discussed earlier and which should be familiar from physical science studies. When matter gains heat, its particles increase in kinetic energy, move more, and become less capable of retaining a stable volume and shape, which we recognize as an increase in temperature. The mass of the matter does not change though, so the increase in volume becomes a decrease in density. Increased temperature and volume encourages matter to move away from the growing pressure and rise. Decrease in temperature and increase in density causes matter to do the opposite and sink. This happens continuously within the fluid layers of the Earth. As rock gains heat deep in the atmosphere, its density increases and it begins to rise towards the surface. If it can escape through a mid-ocean ridge, it will, driving seafloor spreading. At the surface, rock cools, increases in density, and becomes more likely to sink, which it does when compression at subduction zones pushes old oceanic crust back down into the atmosphere. Cycles of rising and falling rock, called convection cycles, appear as a result and drive plate tectonics.